A very good afternoon to one and all. I, Santosh Pandit, welcomes you all on the third day of our 5-day faculty development program on emerging trends in industry. Before beginning with our first session of today, we are very pleased to announce that our resource person, eminent speaker for today is going to be Honorable Sri Tanmay Sharma sir, Engineer, Business Development Education Network, B&R Industrial Automation Private Limited, Pune. Sir's topic for today is New Trends in Industry 4.0. A very hearty and warm welcome to you, sir. On the behalf of KBC Family, Department of Instrumentation and Control Engineering, Nasik, we are very grateful to you, sir, for accepting our invitation as an eminent speaker for our FDP. I extend a cordial welcome to you, sir. A very dynamic personality with a huge experience of about training more than 500 participants in the field of automation industry. May I request Professor Y.P. Patil, sir, to kindly introduce and welcome our today's eminent speaker, Honorable Sri Tanmay Sharma, sir. Over to you, Patil, sir.
Thank you, Pandit sir. Am I audible, sir?
Yes.
Thank you, sir. I deem it a great honor to introduce our today's eminent speaker, Mr. Tanmay Sharma sir, Engineer, Business Development for Education Network, B&R Industrial Automation Private Limited, Pune. Sir has completed graduation from prestigious Amrita Vishwa Vidyapitham's Amrita School of Engineering in the branch of Instrumentation Engineering. Sir has 3 years of experience in the field of industrial automation at B&R Industrial Automation Private Limited, Pune. Sir began his career as an application engineer and worked on many projects serving different industry portfolio. Sir also worked as a trainer in application department to train students, professors and customers on automation products as well as programming softwares. After getting experience of about training 500 plus participants, Sir then moved to Business Development Department under the banner of Education Network. In this role, Sir started interacting with different colleges, professors and students around India with a motto of awareness about industrial automation. Presently, B&R Automation under Sir's leading is working with 40 plus colleges to help them to learn about latest technology persisting in the field of automation industry. This goal is achieved by providing training, giving exposures of hands-on training at various running projects. On this platform, we are happy to announce you all that very soon our institute will be also one of the lucky institute to work with B&R Automation Private Limited in the Nasik region. We are very prosperous to have such a professional, dynamic personality with us for today's session. With this brief introduction, may I request to Mr. Tanmay Sharma sir to kindly enlighten us on topic Industry 4.0. Over to you, sir. Thank you.
Thank you very much, Yogesh sir, and thank you for such a nice introduction. Let me just share my screen and then we'll move forward. Okay. Sir, is my screen visible?
Yes, sir.
Sir.
Visible.
Yes.
Yeah, just a second. Okay. Thank you. So before moving ahead with the our today's session. Just couple of things I would like to tell in advance that one, sorry for the disturbance. There is some small construction going on near my house, so there might be some disturbances, from my end. But please bear with me. I hope that I'll keep this session little bit interesting for you also. In you don't get diverted to the noise. That is the best I can do. So, uh, okay. So thank you for giving me this opportunity and, sharing my knowledge from the industry side to all the, professors uh, available in this particular session. So in this session, in next 1.5 2 hours, we will be looking at different technologies what are emerging in the field of automation, and how industry 4.0 is playing its key role in the development of industry in today's world, especially during the last 1.5 year during the time of COVID, how industry 4.0 is making things better for us in the industry. So with that, I would like to move ahead and discuss a very general topic before moving to the topic of Industry 4.0. That what exactly a owner of a factory or a owner of a site actually wants. Okay, so before going ahead, let us first of all understand what is a factory. What is a site, and what are the different entities inside it. So first of all, we have small machines. Okay, small machines in the sense which do a particular task. Like, for example, let's take an example of chips. Okay, which we get, Uncle Chips or Haldiram chips or any for that matter. So there can be one machine for washing the potatoes. There can be another machine station for peeling the potatoes, then slicing the potatoes and drying the potatoes. So for each and every task, we will have one dedicated machine, or maybe one dedicated machine for two tasks, for example. So like that, we have lots and lots of machines at the ground level. After that, okay, just a second. Let me open one software. Yeah. Okay, sir, can you confirm whether can you see a pen mark on the screen?
Yes, sir.
Yes, sir. Yes.
Yes, sir. Yes, sir.
It is.
Oh, okay, perfect. Yeah. So, what I was telling you was that we may have different machines at the ground level in a factory. A group of machine forms line, and we can have multiple lines inside a factory. So for example, we can have line 1. Okay, line 1 is one production unit. One production unit in the sense they manufacture one product completely. So like that, we can have parallel lines. For example, if I have three parallel lines, I'll be able to do the production at three times faster than normal. So that is called as line. A group of machine is called as a line when they can produce one particular product. A group of lines is called as a process. Okay, now my process 1 can be a chips manufacturing unit, my process 2 can be a chocolate manufacturing unit, my process 3 can be something else. So like that, a factory can produce different products also. So that is called as different processes inside a factory. Now, a group of group of different process is called as a site or a factory, where we give the supply. There are different processes working parallelly. There are different lines working inside different processes, and there are different machine working inside different lines. So like this, we get a output, a simple concept of how a factory works. But now the important part is that what does a owner of this particular factory wants. Okay, so the first and most important priority for any factory manager or owner is that the productivity should be high. Very obvious that, okay, if I have a business, the productivity of the business should be maximum. So when I talk about productivity, we talk about OEE and coordination and availability. So OE is nothing but overall efficiency of the equipment. So OE is, what I can say in very simple language, is a health of machine. Like how we measure human body temperature and different test, blood test and all we do in order to figure out how much good our health is. In the same way, OE is a process through which we find out the health of a machine. Okay, so we want OE of the machine to be high, to be better. Then we want coordination between different processes, coordination between different lines, and coordination between different machines to be good in order to increase the productivity. Then we also want the availability of the machine at the time of production. That means my machine should not, at the time when, I want to produce something inside a machine, the machine should not go into a standby mode or, a mode where it cannot do production. So these things I have to take care. That is the first target of any factory manager. The second target is the quality. Obviously, with increase of the productivity, quality of the product can be little bit can change little bit. So I also want to keep a track on the quality of the product which I am producing. Okay, so it should be according to the standard what is there in the industry. It should also be in sync with track and trace. That means let's take an example of pharma companies. Recently there was a news that I think 10 days back, Cipla and Glenmark, these are two pharmaceutical companies which have recalled a batch of approximately 1 lakh tablet leaves in USA. And why did that happen? That happened because there was some chemical composition issue was there in the tablet, and tablet was not functioning well, and there were some complaints from the consumers. So in this case, what a company will do is company will trace the batch number of the tablet. If you see, whenever we check the expiry of a tablet, next to the expiry date of the tablet there is also a batch number. So I will trace the batch number, that on which date that this batch number was produced, who was the operator at that time, what was the parameters of the machine at that time, what were they correct or not. If they were not correct, what were the batch which was produced before this and after this, and I want to recall all those batches from the market. So all this activity of track and trace is important for industry. For example, Amul milk packets, let's say the milk is not good. Okay, so the company will backtrace that when it was produced, and they will recall the batches. So this facility should be available all the time to keep a track of the quality. And third is monitoring the KPIs. Monitoring the KPIs in the sense whatever target is being set to the machine, that okay, in next 3 hours you have to produce, let's say, 500 packets. So that KPIs of the machine should be monitored very properly. It should not happen that machine is running so fast that there is some damage in the product. So that we have to keep in mind. So point one is high productivity, point two is high quality. And the third, in addition to these 2 points, we also want the maintenance time of the machine to be low. That means diagnostic features inside the machine, asset management of the machine, and condition monitoring of the machine should be done in order to reduce the maintenance time. And when I say reduce the maintenance time, I mean, let's say a Diwali season is coming up and the production need to be very high. And at that particular time, my machine goes in shutdown mode or something breaks down in my machine. So, that is a loss for me. So I have to keep a track that the maintenance should be as low as possible. Point one. Point two, I have to do advance, maintenance of the machine in order to make sure that it do not get shut down during the high requirement period. So these are a couple of things which every factory manager wants. So today in our presentation, we will be learning how to achieve these 3 goals by using Industry 4.0. Okay, now many of you might have very well, seen this particular chart when we talk about, Industry 1.0, 2.0, 3.0, and 4.0. So every industry have a different perspective about Industry 4.0. When we talk about IT industry, they are, doing something else with Industry 4.0, and so on and so forth. But in our case, in automation industry, in manufacturing industry, industry 4.0 is moreover the concept of interconnectivity between the machines, between the lines, between the processes, and also interconnectivity of the factory with the cloud. Okay, so there was time in 18th century we used to work on steam engines and steam applications, and then we moved to mass production concept where one single product was going to get manufactured inside a machine without any alteration for a huge quantity. Then came the concept in 1970s where robotics came into picture, and the mass production was converted into moreover, I can say, customized production. Okay, and the level of customized production, I would just want to share one example. If you go on the website of Cadbury, okay, you will get an option to customize your own gift for your friend or your family or anyone you want. So just imagine how many chocolates are being manufactured in one day. Let's assume, let us say 1 lakh chocolates. That means a machine is producing 1 lakh item per day, and all these items are different from each other. Okay, you can put a photo of your friend on that, and you can write a message about your friend, and that will be getting delivered to the particular person. So just imagine 1 lakh products are being manufactured in one day, and each product is different from other. So all in all, the 1970s was the time when this concept of customized production came into picture. But today in industry 4.0, we are talking about the connectivity between the machines. And why do we need this connectivity? We'll be talking in further slides. So there are different I can say uh, ways in which industry 4.0 can help different types and different applications in the industry. So we are going to discuss these basic 8 parameters through which we can take care to increase our productivity, to increase our quality, and decrease the maintenance time. So let's get started one by one and see how they perform. So first of all is scalability plus. Now, one concept here which I would like to mention to all of you is, or rather a question to all of you, and I want this session to be interactive. So I would expect some answers from you all also. March 2020, the production of sanitizer in India was 8% of the amount of production India is doing today in the field of sanitizers. Now, can anyone explain that, okay, let's say if 8 lakh bottles of sanitizer were produced by, January or February of 2020, from 8, we moved to 100 within 1 month. How was that possible? And believe me, this was the time when there was a lockdown. The companies, a lot of companies were not functioning at that particular time. But then how we were able to move from 8 lakh production to 100 lakh within a month during the lockdown? So any suggestions? What was the concept behind that? Any ideas or any points?
Availability of sugar industry in rural area.
Pardon, availability of
Sugarcane industry helps to produce the sanitizer.
okay, good
So
point. That
here
is
it would be typically rearranging the resource or the resource management and channelizing the uh, raw material, machinery, skill sets, marketing, logistics. Those stuff comes along with the regulatory, or what we call it as a governing will. So once the governing and the regulatory will is in place, then the existing resources, like what is a, so as to achieve the, let's say 100 units, what is my raw material requirement, and what is the machinery requirement, and what is the skill sets requirement. So most of the stuff they were available, and few of the raw materials, they were being restructured. This is like a kind of a, in general, my as a layman view, what it goes. Over to you, sir.
Yes, yes. Anyone else would like to add in this?
Target oriented given by the project manager.
Okay. Yes, good point. Project management is one point. Anyone else? Okay, perfect. So
same batch is run for more amount of time.
Yes, also that is also true. That is also one point. But you know, all the answers were you know, bang on. But also one concept which I would like to discuss over here is, which is you know, one part, as sir was mentioning, that machine availability was there. But another thing what we want to see here is that one machine is designed to do one work. For example, let us take a direct example of perfume manufacturing industry. Now, will everyone agree with me on the concept that sanitizers and perfume have kind of same composition? They both are liquid. They both have alcoholic content in them, and they both are you know, kind of mixing chemical and producing some bottles, right? Perfume and deodorants, what we get in the market. So
Yes,
a
absolutely.
yes, yes. So a machine which is designed to do a production of deodorant and perfumes and ethanol and methanol, these machines, can I use these same machines to do production for sanitizer? Because during the time of lockdown, it is very hard for me to sit and design a new machine, give the order to other company. The other company will manufacture the machine, and you know, generally manufacturing a machine from the scratch will take approximately a year. So that is a very long process which I have to follow. So can I use an existing machine which is doing some other task to fulfill the current requirement? Now, one point which was very much clear in the mind of this cosmetics industry was that uh, in future, during next 1 year, that is March 2020 to March 2021, the demand for the cosmetic products are going to go down because people are not going out. They don't need much of deodorants and perfumes and all these things. But at the same time, the demand of sanitizer is multiplying every day. So in order to keep my functioning, in order to keep my factories you know, in profit, I want to switch over to the application, other application, that is sanitizer manufacturing. And that is only possible if I have a concept called as scalability of a machine. So here in this you know, diagram, earlier what we used to do is we used to design a machine where 75% of the you know, part of the machine was standard machine, and only 25% part of the machine was can be optimized. For example, let us say a CNC machine. A CNC machine can, you know, cut and drill and do different you know, task. That is 25% of the application. But at the end of the day, the 75% of the machine is a CNC application. So this is how earlier the industry was working. But with the time, with the concept of scalability plus, we have moved to a newer concept. And the reason why we did so is, first of all, variety of consumer products. Earlier, we used to, you know, get only one type of Parle-G biscuit in the market. Today, if we go to the market, there are, you know, Parle-G, then there is Parle-G Gold and Parle-G Milk. And, you know, and same is true for all the brands. Earlier, there was only one, you know, Dairy Milk chocolate, a simple Dairy Milk chocolate. But today we have Silk, we have Bubble. For Valentine's Day, we have a new product. For Diwali, we have a new celebration product. So the variety of consumer products which are coming in the market, that is one reason why we want our application to be scalable. That means one machine can do different tasks depending on the requirement. The second is special end customer request. Today, I can, you know, go to a Cadbury website and order a special product for my friend or family. So, and this is the trend right now. if I'm working in my office today and I want to order order a, let's say, a platter, and I want specific content in my food item, food plate. So there are a couple of websites where I can go, I can choose what all I want in my food plate and I can order it. So these are kind of the special end customer requests which are coming up in the market. So that is the second reason. The third is regional requirement. Very simple. So and the fourth point, growing range of options in the market. So because of all these demands which are coming up in the market, I want my machine, which was earlier only designed to produce one simple Cadbury dairy milk. I want that same machine to do production of maybe 50 different type of chocolate. Okay, so now we have moved to that particular concept where only 25% of part of the machine, what you can see, is the standard part. The rest 75% of this part is customizable. That means if I'm trying to make a small chocolate, I can do it with my same machine. If I want to make a big chocolate, I can do that also. And all these features are available within one machine. So this is the concept of scalability which the industry is following right now, where we are focusing on not building a machine which is application specific, but machines which are concept specific. So this is one area where industry 4.0 is getting implemented. And this is because, as I mentioned earlier, it is because of the increasing variety of the special purpose and custom machines. And because of this concept, we were able to fulfill the sanitizer requirement. Now the concept in this is that my cost of standard machine is huge. One machine, one simple CNC machine can cost up to 5 to 10 crores of rupees. So buying a new machine every time there is a new product is going to be very challenging for any factory owner. So in this, what do? We keep the machine as basic, but the variants which we change is just a small cost as compared to the initial machine cost. Okay, so if I want a CNC machine to do drilling, I just have to change the tool in front of the CNC handle. If I want to do a welding, I have to just change that particular part, not the entire machine. So this is a concept of this is a concept of scalability plus, which industry is following right now. The next and most important part is simulation and digital twin. Now, this is a concept through which industry is trying to do R&D and testing on the simulation purpose. So earlier there was a time when everyone who wanted to work in industry wanted to work on the hardware, because they said that more you work on the hardware, the more you are going to learn. But today industry is again moving back to the concept of simulation. Let's take a simple example. I want to design a motorbike. Okay. I make a layout on a paper, I do some sketching and all, I order the parts. Once my bike is manufactured, let's say I put a 50cc engine in my bike and I design it, though it is very low, but let's say I did it. My friend comes to me and after a test ride, my friend says that maybe 100cc of engine will be good with this bike. So what will I do? I will order a 100cc engine. That is extra cost for me, and I fit it in my bike. And I realized the performance of the bike increased. Now, because the performance increased, I want to test 1cc of 150cc of engine in the same bike. Again, the performance will increase, and so forth. I will keep on doing R&D. So every time I do R&D and testing of my machine, I come up with new things which I can improve in my machine. But remember one thing, because I'm developing the machine in a physical manner, I have to order every time I want to do any changes. So that is a huge cost in form of R&D, plus also extra time, because if today I order a part of the machine, it is going to get delivered maybe in 15, 20, 25 days. So there is an extra delay. So today we are, working on the concept of building products, building machines, doing R&D in machines, doing testing in machines on a simulation platform with the help of a concept called as digital twin. Now, digital twin is a why it is beneficial. First of all, it have a shorter TTM, that is shorter time to market. That means if I wanted to design a machine and it took me 1 year to do so, today I can do it in within 5 to 6 months. I can design my machine on a software. I can just by drag and drop I can choose different parts and I can see how the performance is being changed. And once I am satisfied with my machine on a simulation platform, I can start building it on a physical level. And once, because I'm satisfied with the performance on simulation level, I won't have any problem with the physical machine. So shorter time to market is point one. Better ROI, that is better return on the investment. That means I have to order the mechanical equipments only one time. Whatever changes I was supposed to do, I did it already in the software in order to save money. Higher OE, that in machine efficiency, uh, overall equipment efficiency. And how we increase this is with this particular application is, let's say I design a machine and I don't even know that if I change this particular part, the efficiency will increase. Okay, so I cannot play around with my R&D work if I'm doing it physically, because what might happen, let's say if I'm working for a company, I order a part, very costly part, I fit it in the machine and I realize that it is not working, and the company will ask me questions tomorrow that why did you even order this, it's a waste for us. Okay, so efficiency wise, when we are doing it simulation, there is no harm if I put any random part and check the efficiency of the machine, it might work. Okay, so I'm getting the best efficiency of the machine if I'm developing it on a simulation mode. And fourth, easy maintenance. Even though if I test my bike on a simulation mode and my bike falls out or it does not work or something goes wrong with the bike, it's on software, there is not even a single rupee loss for me. But in real, if the bike breaks down, it catches fire, the engine cracks or something because of high load, there is a loss, there is a huge loss. So because of these advantage, the industry is moving towards a concept called as digital twin. Now, when we are designing a machine on digital twin, we are generally talking about three different phase of machine or three different part of commissioning of the machine on simulation. The first is visualization, that is creating the visual effects of the machine. And the software which we can use in this, our very own, very famous, which we use in our mechanical department, AutoCAD. Very simple. Second, optimal sizing and layout. That means I have to tell the machine. For example, if two part of the machine are getting dragged against each other, then what is the friction between these two surfaces? These are kind of the physical parameters of what I'll be giving to the machine. So first is designing the skeleton of machine. Once the skeleton is designed, I have to give physical parameter to that skeleton in order to give life to that particular model which I have developed. And the last part is the software, where I write the software to automate that particular machine. Okay, so these are three different parts. Now, the software which we use for all these three, first, as I mentioned, in the visual part, in the visualization in early phase of the designing, we talk about animations, we talk about flow of material, we talk about collision avoidance. In optimal sizing and layout, we talk about kinematics of the machine, physics of the machine, dynamics of the machine, force, torque, speed of the machine. And last, software, we talk about the software testing, software functioning, migrating to the real machine, and all these topics. The software which we use for all this is kind of very common. For example, for process simulation, we use AutoCAD, we use industrial physics, we use DCS CATIA, and we also long time back we used to use the WinMod. So these are a couple of software through which we can design the physics of a machine. Moving ahead, now there is a concept of machine simulation. which can be done by MapleSim, which can be done by very famous MATLAB and Simulink, and Modelica. These are couple of software which put life in the model which we have produced. And then there is the hardware simulation part, where we talk about running the machine in simulation mode. That means making the machine operational in simulation mode, and that can be done very easily by Automation Studio. Automation Studio is a software by BNR through which we do this particular task. So just imagine, students who are in college, professors can give them this particular idea, make a team out of, 3 students from mechanical, 3 students from our instrumentation branch, and, ask them to do a collaborative work where, the mechanical student can develop a model, and instrumentation students can do the kinematic part and the automation part. So digital twin is a great concept where the things are being done in a simulation mode. So one example, let me share one example. Recently, I think last year, 2020, we got a order from one of the pharmaceutical company in the market. And because, obviously vaccination was going to be a huge thing in market, there was a high demand of injection making machines. Okay, so we got a order to design a machine which can do this particular task. So what we did is that before manufacturing the actual machine, we try to make a simulation mode of the machine. Okay, so for example, what you can see on your screen, towards the right hand side, we have a real machine working, where pelletizing is happening. A robotic arm is picking up and placing injections in the packing tray, I can say. But before designing this real machine, we have designed the simulation of this by using iPhysics, by using MATLAB, by using Automation Studio. We have designed the same. And after doing all this testing on the virtual platform, we went ahead and created a real machine in single shot without any R&D need to be done on the actual hardware. So this is one application which I can tell you. Now this is another application where there is a person using digital twin in addition to AR and VR, that is augmented reality and virtual reality. Without the presence of a machine, the person is able to test this particular setup. And not only test, you can pick up and place the boxes, you can do alterations, you can change anything what is required in real time. So this much amount of complexity digital twin can handle. So I will run the video once again. So the advantage, again, I will mention it that, without even investing a single rupee on the hardware, I'm able to design the entire machine. And once I'm satisfied with the machine functioning, I can actually go ahead and, make the machine in offline mode. Okay, so this is a concept of digital twin, which is again an entity of Industry 4.0 and widely used in the industry nowadays. Third is web-based HMI. Now, first of all, let me introduce what is a HMI. Every machine, every what I can say manufacturing entity need to communicate with humans. That means if I want, I should be able to start the machine. If I want, I should be able to stop the machine. And all the commands a user give to the machine is through a screen called as HMI screen. That is human machine interface screen, HMI screen. Every machine is connected with a screen which is available for the user to start the machine, stop the machine, change the parameters and all these things. So the commands from the user are taken through HMI machine, HMI screen. Now this HMI screen plays a very important role for the machine, because a machine with all the features is useless until and unless the user is not able to control the machine. Okay, so earlier this HMI used to be intact with the machine, but now we are following a concept where this HMI screen can be moved around. That means, let's say if machine is in the factory and the manager is sitting at the home and manager wants to run the machine through his mobile. So can we bring that HMI screen from the machine to his mobile? Or in other words, if the factory is working and manager is in some other country, but manager wants to see what is the status of machine, can that particular manager access the parameters of the machine online? So this is a concept which we are trying to follow here. So let's take again a small example of pharmaceutical company. So let's say we have a process line where there is a machine for tablet pressing. Then the next station is encapsulation. Then the next station is granulation. Then blister packing, and then cartoning. So let me just explain, all these terms in one line. Before making any tablet, the first thing we do is the powder form of the chemical. We press that particular powder form to remove air from it and to make the density of the powder consistent. Once that is done, encapsulation happens where this pressed chemical is getting filled in different capsules, and after that capsules overlap each other, and the packing is done in the granulation station. So generally you might have seen these capsules in the market which are in this particular format, where initially there are two semi cylinders open from one end, and we fill the hard pressed chemical inside this, and they will be pressed against each other in order to complete a full cylinder. So that happens in granulation station. And then there is blister packing, where we get the tablets in market in a leaf, where there are different tablets in a set of 10 or 20 we get like this, and on top of them there is a covering, a silver coated covering will be there to pack them. So that is called as blister packing of tablets. And then last is cartoning. That means collecting all these leaves and putting them in a carton. So let's say I have this particular application and I want to provide internet connectivity to this particular industry. Now, providing the internet connectivity to a machine is the real concept of Industry 4.0, because once we have everything on internet, we can do whatever we want. Okay, so let's talk about this interfacing. So let me just, so there is this particular factory outline which is given to you, and this factory is responsible for blister packing of the tablets capsules. And there is another entity called as WWW. That means the World Wide Web. This is our internet. This is our cloud. We can call anything we want. Now we want to connect this industry, connect this factory to the cloud, but also I have to think about security. That means if I am making a connection of internet between the controller of the machine and the cloud, I need to keep a check on the security so that no third party can access the data. No third party can give a command of running the machine other than the people who actually have the access of it. So in this perspective, we have three different parties. The first party is site manager. Site manager is a device which is kind of similar to the modem, internet modem, what we have at our home, but it's more secure form of that modem what we have at our home. So site manager is nothing but a device which connects all the controllers inside a factory with each other and then collects the data within itself. And once the data is collected from all these all these machines, that the data is collected, this data is passed to the site manager. Site manager with security features will push this data to gate manager. Gate manager is nothing but a cloud service. It can be, Amazon cloud, it can be SAP cloud, it can be Accenture cloud, TCS cloud, or there are a lot of clouds available with us in the market. So this site manager is going to push the data with the help of some security features to a gate manager, which is generally present in the cloud. Once the data is available in the cloud, any link manager will be able to access the data from gate manager upon request. And the controlling point in this particular process is, if you remember, I said that site manager will push the data to the cloud with some security features. So these security features or security parameter should be available with the link manager in order to access the data, so that any third party should not access that particular data. Now, where this can be used? This can be used, let's say, Hindustan Unilever. Now, Hindustan Unilever is an entity you all might have heard. Every product, every daily use product, like, soaps and cosmetics, 60% of the market products in, today are manufactured by HUL. They have more than, 35 factories in India itself. Only in India, they have more than 35 factories. Now, can you imagine how hard it will be to connect with each and every factory and take a status that how much is the production, is there any difficulty with any machine, how many machines are running, how many machines are down, and it will be very difficult for us to maintain the data. Now imagine all the 40 30 plus factories which are in India, all of them are pushing the data to the cloud, and the owner or the manager of HUL can access the data in single shot, where it can compare, it can access the data, it can compare the data, it can take all the actions required, just sitting at one place at any time in the day. That is one application. Second application, there is a machine which is working and suddenly it breaks down. Now, if the machine breaks down, there might be expertise, help required from the manufacturing company. Because if, let's say, Hindustan Unilever is having a machine on the shop floor which is doing production, they have not manufactured the machine. They are manufacturing the soaps. The machine is manufactured by some other company, which might be in foreign or some in another country. So if the machine is shut down and there is something wrong with machine, I have to give a call to them. They will send a IT engineer to me, or a mechanical or a instrumentation engineer to the factory. The engineer will come on site, check the machine, bring it back to the running mode, and then leave the site. This entire process will take a lot of time, traveling and all these things. But on the contrary, if SRM is present, if site manager is present with the machine, the data of the machine can be pushed to the cloud, and that data can be accessed by the manufacturing company who have manufactured the machine. They can analyze the data, that where the machine is going wrong, and until and unless there is no mechanical fault in the machine, they will be able to solve the problem. And how much time it will take? Maybe 1 day or 2. The traveling time is saved. So these are couple of application, where we can implement web-based HMI concept to do lot of benefits for the industry. So this is the third concept. Now moving over to the next topic, that is open connectivity. Now, first of all, why do we require open connectivity? Now, one question to all of you. It's been long that I have not asked any question. How many companies manufacture PLC controller in the market? Can you all name few? How many companies are there who manufacture controllers, PLC controllers in the market?
Siemens, Omron, Mitsubishi,
Mm-hmm.
Fanuc,
Mm-hmm.
Delta.
Okay. Good.
Immersion is also there.
Perfect. Emerson is there. ABB is there. BNR is also there. So there are lots and lots of company and they have their own controller. Now, can anyone tell me on which communication platform Siemens PLC works? What is the communication protocol they are using?
Profinet, Profibus.
Exactly. They are using Profibus and Profinet. So let us take an example that there is a machine. This machine is designed with a Siemens controller, and this machine works in Profibus communication protocol. Let's take it this example. Now there is another machine, I can say, or let's say a robot. This robot have to work with this particular machine. That means whatever production this machine is doing, the robot is supposed to pick up the item and place it in the pallet. And this robot is by ABB, one of the biggest robotic manufacturing company today, like as of now, is ABB, also BNR's parent company. So let us say there is ABB. Now let's say ABB is working on a communication protocol X, and then there is also a third machine also doing some task in this process, and let us say this is with the BNR. It have BNR controller in them. Okay. Now, BNR works on the communication protocol called as PLK, that is Power Link, the fastest communication protocol available as of now. And a lot of other companies are also using PLK. Now, if I give you a situation that there are three friends standing together, one knows only Punjabi, one knows only Marathi, and one knows only Telugu. Can they communicate with each other? And the answer is no. They cannot do it because they do not know how to, they do not know a common language. Okay. So we came up with different concept of, communicating in some, standard languages. In the same way, in industry, the problem, what happened? Okay. Other example I would like to take before this. Do you remember a time when Nokia phones used to come with the thin pin chargers, round pin chargers? So earlier there was a round pin thick charger. Then Nokia came with the round pin thin charger. At that time, Samsung was using its own B-type port chargers. Apple used to have a different charger. Sony Ericsson used to have a different charger. Lava was using different, and so forth. Later on, what happened? The entire industry moved towards B-type charging port. And why? Because the communication protocol, because you remember one more thing, if you remember, the same charging port is also used to communicate data from, mobile devices to the laptop. So the communication protocol and the charging facility was becoming more complicated. For each and every device, there was a different charger. So industry came up with this standard solution called as B-type charger, and now we are moving towards the C-type charger. Now today in market, if you go and buy Xiaomi phone, Samsung phone, Oppo, Lava, whatever phone you buy, other than Apple, other than iPhones, if you buy any phone, they'll come with C-type charger. In the same way, industry also was facing this problem where, every controller manufacturing company was having different communication protocol. Therefore, the factory, inside a factory, if there are 5 machines from Siemens and 5 machines from ABB and 5 machines from BNR, they were not able to talk to each other. At that time, the industry came up with a concept called as OPC UA over TSN. This is a standard communication protocol developed by OPC Foundation, which is backed up by all the companies in the industry. That means ABB, BNR, Mitsubishi, Siemens, Rockwell, Omron, Fanuc, all these companies came together and helped OPC foundation to come up with a communication protocol called as OPC UA. Later on, advanced version of it came as OPC UA over TSN. And this communication protocol is mandatory in all the PLCs. Any manufacturer, let it be Siemens, Rockwell, Fanuc, ABB, BNR, all of these controller manufacturer companies have to include OPC UA communication in their PLC. Other than whatever they are doing, let them do. They want Profibus, Profinet, PLK, Ethercat, Ethernet, whatever they want, let them do it. But OPC UA is must. And because OPC UA is must, nowadays the industry is booming for OPC UA. That means there is a high demand of OPC because this is the future of communication. I can say that at a factory level, there are different machines available. There are some sensors and actuators. There are some robots available on the factory machine. There are some, again, different machines. In order to, create interconnectivity between these machines and also between these machines and cloud. That means between these machines and machine to cloud, we use OPC UA. And not only use, we widely use OPC UA because it's a standard communication protocol. So now I don't even have to, waste my time in figuring out कि Siemens की machine कौन से communication protocol पे है और उसकी machine कौन से protocol पे है. I can simply go ahead and use OPC UA. Let it be any manufacturer. Now, OPC UA is something more than just data. That means, first of all, it is open international standard. That means it is widely accepted by all the companies. And it deals in the terms of information, not data. That means if I publish this data in front of your eyes, you won't make any sense out of it. Okay, so this is how machines communicate with each other. But OPC UA will give you information, not the data. Third, end customer demands. End customer demands are, if I'm an end customer, let's say if I am HUL, manufacturing different products for the market, I don't want to break my head with different machine. I don't care if the machine is from Siemens or the machine is from BNR. What I care at the end of the day is my production should happen. Okay, so that is the place where OPC plays a key role. Then plug and produce. That means today, let's say I am using ABB robot and tomorrow I want to switch over to some other robot. I can just remove ABB robot and bring another robot and plug it in because I know it is communicating on the OPC UA platform. That means the communication will be possible with any other robot also. So a plug and play can be done. And in 2018, it was the largest ecosystem. That means the maximum machines in the market were using OPC UA. And also another key feature of OPC UA is integrated security. OPC UA comes with very, very, very high level of security as compared to any other communication protocol in the industry. Because the data is also pushed in cloud by using OPC UA. So whenever we talk about internet, we can talk about hacking and malware. And in that case, we have to increase the security. So this is about concept of open connectivity, in which the industry is moving towards open connectivity with high security, and that is the technology called as OPC UA over TSN. Okay, so so let's move to the next topic, that is IoT for brownfield and greenfield industries. Now let us talk about these 3 points. We want to connect individual machines or lines. That is our task 1. We do not want to impact our install based, that means current hardware which is there with me, and better data transparency. So let us understand these 3 points. I let's say started a factory in the year 2000, let us say. Okay, and Yes. Just give me a second. I'll have some water. Just give me a second. Meanwhile, if any one of you have any question, please post it in the chat box, and I'll be discussing them. Okay, perfect. So let us say I have purchased some machines in the year 2000, and I have done a huge investment by setting up the factories. And later on, I realized after 15 years, these machines are very old. The technology in the market have changed drastically. And there is a concept of Industry 4.0, there is a concept of robotics, which was not there earlier. And all my machines are outdated. Now, should I go ahead and throw out the old machines and purchase new machines? If so, if that is the only solution, then I'm going for a huge loss, because old machines no one else is going to buy. I have to obsolete them. I have to make them obsolete, and that is a huge loss. And also I have to procure new machines, heavy machines, which can cost me in crores. Okay, so industry started thinking about a technology through which I can enable old machine. I can enable old machine in order to connect, or in order to make them capable of Industry 4.0. Because a machine which was built in 2000 is a outdated machine, and Industry 4.0 cannot be implemented. The concepts of Industry 4.0 cannot be implemented on those machines. For example, OPC UA communication protocol came now in the year of 2012 2013 onwards. So a machine which was a PLC which was manufactured in 2000 do not have that capability. So industry started thinking about a solution where brownfield industry means old industries which are not capable of implementing Industry 4.0, and greenfield industry means industries which are new and are capable of implementing Industry 4.0. So industry started thinking, can we have a solution which can change a brownfield industry into a greenfield industry without changing the machines? And that was done by Orange Box. Orange Box is a solution which gives you a extra, what I can say, platform which is resembling to Industry 4.0 and will give you all the benefits of the same. For example, the concept of OEE, that is overall equipment efficiency, came in Industry 4.0. But if I want to implement OEE, or if I want to check OEE for the old machines which are very obsolete, I can simply install Orange Box with that old machine, and my machine will be able to give you that particular data. My machine will be able to communicate on OPC UA. I can access any data and analyze it on Orange Box. So this is a technology which is widely used in the industry, because believe me, India is a manufacturing space where we are very fond of doing less investment. Industry moved very fast when we talk about other countries. When we talk about manufacturing in USA, Europe, China, manufacturing moved very fast and the changes were brought in very fast, but India is somewhere down the line lagging behind. Like for example, concept of Industry 4.0 came in the year 2008 or 2007 in other countries, but in India the concept of Industry 4.0 started coming in year 2015. So you can see the delay. So in this scenario, in this existing Indian market, Orange Box is a very good solution which can be used with brownfield industry and convert them into greenfield industry. So that is one area which you should look at. Now next is edge architecture. So we talk a lot about process automation. Okay, I know like you also had couple of sessions on process automation, but Industry 4.0 plays a very important role in process automation. And how does it happen? Let us go in detail for this particular topic. There are a lot of hardware connected to a machine. There are a lot of sensors, actuators, motors, drive, and panel and vibration sensors, and lots and lots of things are connected with the machine. All these connected items generate data. Okay, so there is a there is a huge amount of data which needed to be collected. That is called as aggregation of data. So first step is sensing the data. Second is aggregation of the data. Third is analyzing the data. And fourth is controlling the machine based on the data. That means what I'm going to do, I'm going to collect the data from the machine, analyze the data, check whether everything is working fine or not, whether the production is fine, the speed is fine, there should be no damage to my machine, and if anything needed to be corrected, then I will take action on that. So that is called as a closed loop production. And this is nothing but a part of OEE. Now, process automation, I can say the different features of Industry 4.0 are these. First of all, controlling the data, or I would rather say controlling the machine. Second is providing security to the machine. Third is providing internet connectivity to the machine. Fourth point is data aggregation from the machine. Fifth point is data historian. That means creating a, or I can say, keeping saved the older data. That is also a part of Industry 4.0. Then providing business intelligence to the machine. That I should be able to provide this intelligence to the machine that, okay, if you want to do a production of, let's say, 500 packets, machine can run at speed of 20 packets per minute and finish the production in 10 hours, and machine can work at double the speed and reduce the time. But I should be able to give something to the machine through which the machine can analyze itself. Is it fine for me to run for that speed? Is it fine for me to run at double the speed? If not, I can face couple of a small loss in production, but I cannot face the loss of damaging the machine. So I have to provide this intelligence to the machine, or the mind to the machine, where a machine should be able to communicate with me and tell that, okay, boss, this is not possible. You are putting a lot of pressure on me for production. I'm not going to work at this speed. I'm restrict myself to only this speed. That is the maximum best I can do in current scenario. Okay, so this business intelligence I have to provide to the machine. Also, machine learning. So we are not going to go in detail about machine learning, but I have to provide a platform to the machine where it adapts to the situation in which I am making it run. Okay, so that is called as machine learning. Then long-term storage of the data. So these are some of the key features, key features of Industry 4.0. And how can we implement that? That depends on case-to-case basis. So the first case is Edge Connect. Edge Connect is nothing but controlling a machine with the edge technology, edge controller technology. In this, we will be able to provide control of the machine. We will be able to provide security to the machine. We will be provide internet connectivity to the machine, and we will be able to provide a small amount of data aggregation. But if I want to do a data historian, business intelligence, machine learning, long-term storage, I have to rely on the cloud services. That means I have to push this data to the cloud, and I have to purchase a third-party company to analyze and do all those things, and then provide me with these facilities. So I have to rely on the IT companies, that is the cloud services, for these things. But if I go with the embedded edge technology with Orange Box, as we discussed in the previous slide, it's a device which is used to convert brownfield industries into greenfield industries. So if I want Orange Box, if I want data historian and data aggregation on my machine level itself, on my factory level itself, and I do not want to include cloud in that, then I can go a level higher and I can provide control, security, internet connectivity, data aggregation, and little bit of data historian to the machine with this solution. But still, the business intelligence, machine learning, and long-term storage need to be done through cloud services. Then comes the third option, where in addition to all the previous features, we are able to provide complete data historian, we are able to provide business intelligence, and also small amount of machine learning to the factory without using the cloud services. And that solution is called as APROL. APROL is a solution for process automation. Okay. And also, other than that, we have also server based edge controller, where the same thing can be achieved, but server based edge controllers are generally little costly, and the maintenance is very high because it's based on the server. And whenever you go ahead in the market and procure a server license and server setup, it is very, very costly. So these are couple of solutions available in the market to implement Industry 4.0. Now, the important part is, why are we doing this? Why do I need internet connectivity? Why do I need data aggregation? Why do I need data historian? Why do I need to store the data for long term? Let us look at this from a different perspective. Data is, first of all, everywhere inside the factory. There is process data, there is production data, there is machine data, there is quality data, and this data is being generated from different machines, different lines, different processes, different sites, and all this data is taken into APROL, and different analysis is being done inside APROL, and then we get different parameters like ERP of the machine, data warehouse, enterprise, internet, MES. Let us look at from a different angle. So I would like to go on another slide, just a second. Okay, so let us come to this particular concept. Energy consumption. So let us say the amount of energy consumed by machine while running for 10 hours on the first day is let us say X, and the amount of energy consumption of the machine for running for the same hour on after let's say 5 years of working is X plus 10 megawatts or kilowatts, whatever that can be. That means there is something wrong with my machine. If day one my machine was running with X energy consumption, why there is an increase in the energy consumption? That means there is some problem with my machine. Secondly, vibration. On day one, my machine was vibrating below the danger level. Today, my machine is vibrating at a level which is little bit critical. That means there is a problem with the my machine. Another thing, control cabinet monitoring. Like, what is control cabinet? Control cabinet is nothing but the electrical a cabinet which contains all the important electrical hardware inside a machine. That means your controllers, your drives, your motors, your input output modules, and all these things are put inside a cabinet. If the temperature of cabinet goes high, If the humidity inside a cabinet goes high, that means my machine is in danger. And how I came to this conclusion that, through energy consumption, my machine is in danger level, or through vibration, I'm in danger level, or through control cabinet monitoring parameters, I figured out I'm in danger. All this happened after I analyzed the data. And the data is nothing but energy data, vibration data, and cabinet data. So in the same way, this data is produced on a very huge level inside a factory, and this data need to be analyzed in order to make some sensible decision for my machine or my factory, and this is called as big data. Now there are 4 parameters on which we judge a data. First of all, there is a volume of data. That means scale of data, that how much amount of data I have. Then comes variety of the data. That means different forms of data. So for example, there is energy monitoring data, vibration data, cabinet control data, and so on and so forth. The next front is veracity of the data. That means uncertainty of the data. How much error can be there in my data? Plus minus 1% or 0.5%. How much uncertainty of the data is there, which I'm receiving. The last, velocity of the data. That means the analysis of the data. All these 4, when I judge my data on all these 4 fronts, I will be able to come up with a value of the data, that how much important the data is. If it is important, I will take it up. If it is not important, I will not reject it, but I will put it aside for the time being. And depending on this value, that how much important the data is, we can do either big data analysis or a simple data analytics. Simple data analytics can be achieved by machine controllers. But, we discussed in previous slide, like orange box and different products are available with us. But if I want to go for big data analysis, I have to go with cloud services. And these services, either by doing big data analysis or normal data analytics, we will be able to come out with certain results out of it. Whether my machine is fine or not, whether my production is going to be fine or not, what is the health of machine, is any part of the machine is broke or not, so that I can order that particular hardware in advance and keep it ready in case if it breaks. Okay, so this is one very important part of Industry 4.0. That means you should be a person should be attached to the machine in such a way that we know everything about that machine. Obviously, machine do not have a mouth to communicate its problems, but we should be able to know all these things about our machine. Because one thing we should keep in mind, if one machine or one line breaks down, entire factory goes down, or the majority of the part of factory goes down. And when the factory goes down, there are huge losses. There are losses in production, there are losses in salaries. If 5 days my my factory is not working, I still have to pay my employees. Okay, so these factors are very important to keep in mind. The next concept is of predictive maintenance. Now this is very interesting concept of Industry 4.0. Now one question to you all again. It's been long, I did not ask. So I believe all of you might be having some or the other type of vehicle, a car, a bike, or some or the other type of vehicle will be available in our household, or maybe a cycle or anything for that matter, a Activa, scooty or anything. I would like to ask all of you, when do you take your vehicle for service? On what you decide that, okay, today I will take my bike on service? Anyone?
Unless the vehicle starts trouble.
Okay, that is point 1, that whenever there is a problem in the machine, I will maintain it. That is one way. Any other way, anyone?
With a
Release
schedule.
monitoring.
9.9 kilometer schedule.
Okay. So second point we got is on a regular basis. Every 3000 kilometer, I will change the oil of my vehicle. So that is called as scheduled maintenance. Okay, that every 1 year I will do maintenance of my machine. Okay. Anyone else? Any other concept?
Condition monitoring by observing
By
quality of
observing.
oil.
Yes, very good. By observing.
Any new vibrations, like say any new sound comes, we figure there's some problem.
Yes, correct, very correct. And the type of service I give to my bike, I have a bike with me, and the type of service I give to the bike is जिस दिन रास्ते में बंद हो जाएगी धक्का देके लेके जाएंगे. Okay, that is another type of service we do to the vehicles. And I have ended up in a lot of trouble many times because of that. Okay, so in the same way, we have machines in industry which are running continuously. Now we have to maintain these machines, obviously, but on what basis do we do the this maintenance? Now there are majorly there are three type of maintenance what we can do. One, as we discussed, a regular maintenance, that every year this is the time I will do the maintenance. For example, what should we take? Let's say biscuit manufacturing industry or chips manufacturing industry or namkeen manufacturing industry. Can anyone tell me what is the time they should choose to maintain their machines? Snacks manufacturing industry.
In between batches.
In between batches is fine, but which time of the year, like January, February, March, which time of the year they should choose? Ideally.
When the demand is less from the market.
Okay, but let us say throughout the year, we like I eat biscuits all throughout the year. So the demand is going to be constant. Maybe it might increase sometime, but continuously there will be demand throughout the year. What can be the other concept of scheduling that service or scheduling that maintenance time?
After the March end, April, May, in the month of April, May, or availability of the.
Okay, so may I know the reason why this particular time?
Availability of the standby machinery.
Okay, availability of standby machine. Okay, rather than I will give you a new concept. May, June, July. These are the 3 months where food industries are generally, during these time they generally schedule the maintenance. And the reason behind that is it is rainy season. In rainy season, there is a lot of moisture in the air, and this moisture decreases the quality of the products. For example, if you manufacture biscuit at that time, they are going to be soft. They are not going to be crispy. Okay, so this is the time generally when food industry do maintenance because of moisture. Point one. Second point also, once I pack the product inside a wrapper, it becomes safe because it is airtight. But the time during the production, it will be outside. It might, because there is a moisture, there is a lot of germs in the air because of moisture, and some germs might go in the food, and even after packing them, germs have already gone inside and they will spoil the food. Okay, so there are these particular type of situation where they do maintenance. Now another time, let us say another example, what can we take? PID controllers. Let us say I manufacture a machine in Pune, and that machine is, let's say, a plastic molding machine or a blow molding machine. Now it works on the concept of PID. That means PID have to maintain the temperature of the plastic so that it stays in the liquid form. And then I make bottles, chairs, and buckets out of it with these machines. Now, if I manufacture that machine in Pune, if I send this machine to let's say Jammu and Kashmir or Himachal Pradesh. Himachal Pradesh, there is a very good place called as Baddi. Baddi is a place where, you know, lots and lots of industrial manufacturing is happening in Himachal Pradesh. If I send the machine to Himachal Pradesh with the PID parameters what I have set in the environment condition of Pune, will my machine work over there? No. I have to reset the parameters. Even though if I reset the parameters during the season when there is a snowfall, will the machine work? No. And changing the PID parameters of machine is not that easy. If I talk about cold storage, if I want to do auto calibration of PID parameters of cold storage, it will take me 3 months to do it, because a cold storage, you know, the temperature of the room, to increase it by 1 degree or decrease it by 1 degree, I have to do lots and lots of activities to increase or decrease that particular temperature. So generally, you know, industries in Himachal Pradesh do their maintenance work in the season of cold, that is during the season of snow. So that is one type of predictive maintenance. One type of maintenance, that is our scheduled maintenance. The second type of maintenance is how I do to my bike, that जब तक चल रहा है चलने दो, जिस दिन बंद होगा उस दिन देखेंगे. This is second type of maintenance. Now the problem with this is, if I'm going to office and my vehicle breaks down, I'm going to get I'm going to face some problem in my office. That means in machine, if machine breaks down at the time when there is a high demand, I am going to face a very huge loss. Diwali is coming up, I am running my machine at full capacity and my machine breaks down before the Diwali seasons. My entire year profit depends on the Diwali season, because for the entire year I am just maintaining a balance on, you know, profits and expenditure. But Diwali is the time when I'm earning, or Christmas is the time when I'm earning, or New Year is the time when I'm earning. But at this time, if my machine goes down, I'm going to face huge loss. This is second type of maintenance. Third type of maintenance is predictive maintenance, and the type of maintenance which is done by Industry 4.0. So we discussed this pyramid. This is called as automation pyramid. So we discussed this pyramid earlier, where, you know, we have different components at the lower level, like sensors, actuators, and all these things. Then we have shop floor data, and then we have process data. Then we have a plant data. Then we have a ERP level data. That means enterprise resource planning data, which happens in the cloud. So device level, we have sensors and actuator. Control level, we have machine, line, cell controllers. Supervision level or the process level, we have DCS, SCADA. And then we have MES level, that is manufacturing as execution system of the entire plant. And this data is pushed to cloud with the help of either MQTT communication protocol, or, as we discussed earlier, OPC UA communication protocol. Now this data which is pushed to cloud can be of any type, as we discussed: energy data, vibration data, motion control data, cabinet control data, analog values data. So all this data is pushed to cloud, and my cloud is going to, you know, analyze all this data.
Database in normal form. And consider one more course. This is about writing SQL.
Okay, some have one.
What I do is, for my undergraduate program, all these.
Okay, yeah, fine, no issues. Yeah. So all this data from you know, different parts of the machine which I am collecting, I push this data to the cloud. Let the cloud do all the analysis, and let the cloud tell me that, okay, the vibrations are high, your machine need maintenance. Your temperature of your cabinet is high, your machine needs certain maintenance. And not only it will tell me that my machine needs maintenance, it will also tell me which part of my machine is not working properly. For example, there is a conveyor belt going from 4 motors. let us say I have one motor here inside the machine, or one here, one here, one here, and let us say there is a conveyor belt going over all the 4 of them. Okay, now temperature of the conveyor belt from this region to this region is high. That means the machine temperature is increasing. That is fine, that everyone can know. But how will we know that which part of the machine is having high temperature, and inside that part also which particular place I'm having high temperature? So if I am having high temperature here, then is it the high temperature of the motor which is the problem here, or it is the high temperature of the conveyor belt because of wrong tension is being applied? So all these analysis all these results I will be able to find if I get the result from the cloud that, okay boss, your machine's temperature is high, that is point 1. Inside your machine, there is a conveyor belt with 4 motors, and this particular part of the temperature part of the machine is having high temperature. And inside this part also, the motor is having a normal temperature, but your conveyor belt is having a high temperature. That means there is some problem of torque and friction, and because of that, it is getting degraded. Even the conveyor belt is getting degraded. So with this, I should be able to know before my machine breaks down. I am already ready with the solution. Before the machine breakdowns, I will order the part, and I will, soon it will come in my machine. And one fine day, when I have the least demand from the market, I can shut down my machine, do the maintenance, knowing that there is a Diwali season coming in front of me. Okay, so this concept is called as predictive maintenance, when we predict that when my machine is going to break down. Okay, this is the concept of predictive maintenance. So for this, we require, big data analysis, where, in future, there is going to be a huge amount of data. For example, in past we used to have 50 MB of data produced from the machine. In present, we have approximately 2.5 TB of data being produced on an average. But in future, the amount of data what we are going to have in the amount of data what we are going to have from machine is going to be very, very huge. And for that, we will be requiring big data analysis. And this is the place where Industry 4.0 comes into picture and plays its crucial role in big data analysis. Okay. So this is about predictive maintenance, which we do through Industry 4.0. The last is mass customization. Now, I want you all to see this particular video of mass customization, and then we will discuss it in detail. Okay, so can anyone confirm, was there audio in the in this video?
We are not getting audio.
Okay.
No, it is just video. I'm not
No
getting.
issues. Okay, no issues. But anyway, this was there was just music behind it. So let me, yeah. Okay. Okay, so let me just explain this particular video about adaptive manufacturing. Now, there was a time in, what I can say, there was a time earlier when industry used to have a standard conveyor belt system kind of a production. So, for example, let us say this is okay. So don't look at this particular part right now. Just look at the boxes which I have made down. Let's say these are different manufacturing stations in a automobile company. Okay. Let's say our first station is for placing seats. Second station is for placing the bonnet of the car. Third station is for placing the tires. This is maybe for paint. Okay, some random functions they are doing to manufacture a car, for example. Now let us say to fix tires inside a car, we hardly need 2 minutes. A robot hardly needs 2 minutes to bolt tires to the car. To fix seats, maybe it might require 5 minutes. And for paint, it might require 10 minutes. Now, there is a conveyor belt through which cars are being moved from this direction to this direction. Now, can you tell me, assuming, let's say this take also 2 minutes and this station also take 3 minutes. This is the entire production line. Can anyone tell me how much time will I require to produce one car?
Sir, 10 minutes.
No, not 10 minutes exactly, but yes, there are 5 stations. The problem is, even though this station takes only 2 minutes to do its task, the movement of car from this station to this station will happen in 10 minutes. Why? Because this process is taking 10 minutes to complete. Are you getting the point? Like the time delay. So there will be 8 minutes of time delay here. That means even after the process is completed, within 2 minutes, it will take 8 more minutes of waiting to go to the next station. Same like here, it will again, for the shifting purpose, it will take 10 minutes. Same 10 minutes of time it will take here. And same 10 minutes of time it will take here. That means I am going to get one product out of my production every 40 minutes. That means if I give a input here, I will get an output of after 40 minutes. And how much of delay is there? There is a delay of 8 minutes here. There is a delay of 5 minutes here. There is a delay of again 8 minutes here. Okay, so I am losing a lot of time. And why I am losing time? Because I have the conventional conveyor belt system. That means या तो सब कुछ आगे जाएगा या सब कुछ पीछे आएगा. I cannot control the stations individually. I cannot control the movement of cars individually if I am having conventional conveyor belt system. Now, in order to overcome this particular problem, we have this concept of EcoPOS track. Now, I will be yes. So I will be showing you. I will be pausing this video in middle, and I will be showing you. Okay, I can pause it. Yeah. Okay. Oh shoot. So there is little bit problem with my menu bar. Yeah. So I will do it in small screen. It will be better. Okay. So this is nothing but a conveyor belt system. Okay. And this conveyor belt system is not a what you can say conventional system. It works on the application of magnetic field. Now how it works, let us see. Okay. So there is this round line which we have made, and this metallic line what we have made have a magnetic field which is holding these shuttles. These shuttles are nothing but the carrier on the metal. These are small carriers which are holding some product. In this video, these orange the spherical orange items what we have is our product. So these shuttles which are running on the metallic surface and running with the help of magnetic field is called as EcoPOS track. Now the advantage of this is I can control each and every shuttle individually. That is one advantage. That means I can move any shuttle whenever required. If there is a space, I can move it further. For example, let us just wait for this. So this is like maintenance. Okay, I have just plugged two shuttles, and these two shuttles will go and join the production, and another two shuttle will come for maintenance. That means without even shutting down my machine, I will be able to do maintenance. This is second application. Now, I would again like to all of you to see this particular part. Now I am getting shuttles from this direction also, and I am getting shuttles from this direction also. So from both the direction input is coming, and the exit line is only one, that is towards this. So there might be a collision, but because I can control each and every shuttle individually, my machine have the capability to do collision avoidance. That means they can pause themselves and wait for the other shuttle to pass, and then accordingly it can be controlled. Then in this particular example, we let me just rewind. Yeah, so I have a camera system over here to decide whether my product is good or bad. If my product is bad, it will go in this particular line. If it is good, it will go in this particular line and will get packed. Okay, so all these individual on the other hand, if I had a conveyor belt system over here, conveyor belt system, I cannot control the diversion very perfectly. There will be some errors. Okay, so that problem can be avoided by EcoPOS track. So this is one example of how the conveyor belt system, the track technology of the industry is changing from conventional conveyor belt system to advanced EcoPOS track. Now another advantage of this particular technology is, if today, let's say I set up a conveyor belt system, tomorrow I cannot change it because the length of conveyor belt cannot be increased, decreased, there cannot be any bends inside that and all these problems. So every bend I need to put a pulley over there in order to do that. But this EcoPOS track system comes with different parts with different degree of bend and a track or a what I can say a architecture can be created on based on the application. So this is flexible. So today if I want to make architecture A and tomorrow I want to change it, I do not have to do any extra investment from the scratch. Okay, I can use my old parts. So let's say this is one example. Okay, this video which is playing on your screen. So there is a robot and there is these shuttles are moving on the conveyor belt system. Without stopping the machine, I can take out that particular shuttle and I can replace this shuttle. So without shutting down the entire machine, I can do the changes. Okay, so this is one application of EcoPOS track. Moving ahead, the flexibility part, what I said, that you can build any type of architecture today, and tomorrow if you want to change, you can change it in any manner. So it is future proof. You do not need to do investment again and again. The last but not the least part, that is reconfiguration for unforeseen requirements. That means today I might not have some requirement, but tomorrow I might need to change it. Okay, because I never know that tomorrow what will be the demand of the industry. But if I have conventional conveyor belt system, I have to do a lot of changes. If I have EcoPOS track, I can again make it flexible. For example, here let us say I have 3 stations, station A, B and C, doing the production. Tomorrow the production might get increased and I might face a requirement of extra stations. So I increase the length of the track, this particular track technology, and I might have station B1, B2, B3 and A1, A2 and C1, C2. Okay, tomorrow there might be demand for more stations, so I can have some stations in parallel, and individually I can move the items over this conveyor belt. Okay, so this is about unpredicted productivity requirement in the future. And third is, when there is a conveyor belt system, there are the conventional conveyor belt system, there are some jerks. For example, the top and bottom movement of boxes containing the liquid you can see. So in the bottom one you are facing jerk, but the top one is doing the same task in the same time, but the jerks are less, so there is a less chance of damaging the product. So these are couple of advantage of track technology, what you can see. And also in addition to that, now we have moved more than track technology, we have moved to EcoPOS 6G track. So maybe after the session you can just go on YouTube and Google out about EcoPOS track and super track, and these are the adaptive manufacturing technologies which we are having in the market, which are industry 4.0 enabled. So that is all from my side in today's session. I just try to give you introduction about different areas where industry is working right now in the field of industry 4.0, and all these verticals are going to be very hyped in the future, because the demand is increasing rapidly for these advanced technology to be implemented in the industry. So with that, I would like to end my session. If you have any doubts and queries, I'll be very happy to answer them. Also, if you want to have some discussion with me off or after the seminar, these are my contact details on your screen. My mobile number and email ID is there. You can call me up or contact me anytime. Thank you for having me, and let us look if we have certain doubts.
Yes, thank you very much, sir, for enlightening us with the in-depth technical knowledge relating to emerging trends in Industry 4.0. Very conceptual session, sir. In a very precise way, the session was conducted right from machines to the site. How productivity, quality, maintenance is to be achieved by Industry 4.0 was explained by you in a very perfect manner. The scalability, digital twin, web-based HMI, open connectivity, OPC, UA, communication protocol, IoT in greenfield industry, edge architecture, product maintenance, mass customization. Sir, wonderful session. We expect that after this session, the concepts regarding emerging trends in Industry 4.0 are very much inbuilt in the minds of our participants. So thank you very much, sir. Really, Industry 4.0 has crossed a milestone in the field of automation. Once again, I will appreciate the efforts put by you for last 2 hours. Now it's a question and answer session. I request all participants to actually participate in question and answer session by kindly unmuting yourself, or you can put the question in the chat box. Over to you, participants.
Thank you, sir, for appreciating the efforts. And also, like, I can see one question. Just a second.
Yes, sir. It is a question from Mahesh Bhagwat, sir.
Yes.
Asking that if ladder logic drawn in AutoCAD and it is directly merged in PLC, is it possible?
Sir, actually, AutoCAD is a software which will give you architecture of the machine. That means, it is going to do the physical designing of the machine. Once the design is completed, by AutoCAD, then this AutoCAD model will be transferred to iPhysics. iPhysics will do the parameters, take care of the parameters of the machine. For example, if there is a conveyor belt inside the machine, what is the tension in the conveyor belt? That will be given by iPhysics. If I'm, a box is sliding onto the conveyor belt system, that means what will the friction between the box surface and the conveyor belt surface? So step one is AutoCAD for just manufacturing the model. Step 2 is iPhysics for giving life to the model. That means giving physical parameters to the model. And the third step is programming, either in ladder logic or structure text or any possible way. But I don't think, through AutoCAD we will be able to program there and there itself. So it's a step-by-step process where we need to have 3 different software for doing one project.
Okay, thank you, sir.
Okay, thank you, sir. So next question we have, which is one of the best PLC system for pharmaceutical industries? No, none are there. I would say all the PLCs in the market are same. They do the same task. And it is nothing like any special PLC is designed for pharmaceutical industry. Any PLC can control the task in pharmaceutical industry. The only thing is how good is your programming inside the PLC will make your machine more effective or less effective. So that is the point. It does not depend on the PLC. So I believe all the companies in the market have a kind of, same features what they are giving in their PLC. Moreover, yes, there are some plus and minus about, different PLCs, but I think all the PLC will be able to do if the configuration of PLC is right. That means the processing power of the PLC is right. If it's not a low processor, because there are certain tasks where low processor can work, there are certain tasks where we need high processor. So if you are choosing the correct PLC of that particular company, it will work very properly. Okay, anything else? Okay, is there a scope to have research with predictive maintenance? How to start with it? Yes, there is a huge scope in predictive maintenance, and predictive maintenance can be done in a lot of manner. There are different sensors available in the market, like temperature sensors, vibration sensors, and humidity sensors, which can be installed inside a machine. The parameters can be taken by using Python. Big data analysis can be done, and a model can be created to do this predictive maintenance. Couple of professor and students from Mumbai and Pune region are also doing have taken up this predictive maintenance as their projects. I know a couple of professors who are doing their PhD thesis on this particular topic. So yeah, so if you want to discuss more about predictive maintenance, maybe we can get in touch offline, and then I can assist you more about how to get more information about these topics. And for study and research work, which equipment or machine should be considered in case of PDM? Okay, So machine and PLC, I would rather say for the basic research and R&D purpose and testing purpose, I would say any PLC will go handy. Whatever PLC you have, let it be BNR, let it be Siemens, Mitsubishi, I think all of them are good enough for R&D purpose. But moreover, the important part is gaining the knowledge of their software is kind of more important. It's all about if I give you a very hi-fi mobile or a very advanced mobile, I won't be able to, I'm not comfortable with iPhone, for example. So if tomorrow someone buys me 1.5 lakh of iPhone and give it to me, I won't be able to use all the features of the same. Okay, so it's the same. So it does not depends on which machine should be used or which equipment should be used. The more important part is whatever equipment and machine you are using, you should be very much comfortable working on that equipment. You should know all the features of that. So that is what I
Hello.
Yes, sir.
Yeah, good evening, sir. Professor Ankush Gunde here.
Yes, sir, Ankush, sir, from
Yeah,
Bharati Vidyapeeth. You are
yes,
also
yes.
there in the session.
Sir, yeah, sir. So very informative and interactive sessions. I am thankful to you and the coordinators for conducting such a wonderful session. Sir, my question is, what are the research area for the faculties in this industry 4.0 or big data analytics?
Okay. So first of all, let me just clarify. We BNR have worked with Bharati Vidyapeeth in past, and Ankush Gund sir was part of one of our training, I think in 2019, if I'm not wrong. So I know Ankush.
Yes, sir. Yes,
from
2019.
that.
Yes.
Yes. So yeah. So the research topic I would majorly focus on, first of all, predictive maintenance. That is one. The second is digital twin, because and moreover predictive maintenance I would focus on digital twin, because digital twin is a field where it is based on software. The investment is not much, and the knowledge which we gain is kind of everything, because inside the simulation we are designing a machine, and after designing a machine we are controlling the machine. सो सब कुछ आ गया उसके अंदर, लाइक पूरा प्रोसेस उसके अंदर आ गया, डिजाइन से लेके फिजिकल पैरामीटर से लेके प्रोग्रामिंग तक, एवरीथिंग इज इट्स इन द पैकेज. सो डिजिटल ट्विन इज माय फर्स्ट प्रेफरेंस. Second is predictive maintenance. Third is data analytics by using not through the IT ways but by using the PLCs. That is the third thing. So for professors, I will suggest these three topics. For students, I will rather say that, before moving to these particular topics, students should be more focused on basic learning of PLC. And once they are comfortable with basic learning of PLC in second and third year, then, there might be, advanced project on these three topics in their final year.
Thank you, sir. Thank you.
Welcome, sir. Welcome. Any other doubts from anyone?
Good evening, sir. I have one question. Very informative session, sir. I want to ask you a question that machine learning is very useful in the industry or organization?
Okay. Yes, sir. So thank you first of all for appreciating the efforts. So machine learning. Okay. How should I explain this it to you? Okay. So machine learning is something where let's say I give you again same example. Let's say I give you a mobile which is very hi-fi, which you have never seen in your life, or any machine, let us say for that example. Will you be able to take the most benefit or maximum benefit out of it? The answer will be no. Until and unless we do not know about the features of the machine, we are not going to use them. We are not going to take advantage of them. Okay. In the same way, machine learning, both machine learning for the user and machine learning within itself. That means The user should be very much comfortable with the machine. That is one part of machine learning, and a machine should be able to learn itself. This is the second parameter. I'm talking in very basic term here, this machine manufacturing. So these two things are very much important and will be required on a very huge level in the future.
Thank you, sir. Thank you, sir.
Welcome, sir.
Any other participant, please?
Okay, if I also have posted my contact details in the chat. If anyone want to get in touch after the session, most welcome to do so. Thank you, sir.
Yeah, thank you very much, sir. Now we will proceed with our FDP session. If anyone having any doubt, kindly contact us through the contact details. And now I request Professor Y.P. Patil sir to kindly present the vote of thanks of today's session. Over to you, sir.
Thank you, Pandit sir, for giving me this opportunity to present vote of thanks for this session. Sir, am I audible?
Yes.
Oh, thank you, sir. We will like to express our profound gratitude to our eminent speaker, Mr. Tanmay Sharma sir, for enlightening us on various aspects of Industry 4.0 with respect to industrial Internet of Things, such as sir started with detailed exposure on what every factory manager wants. That question sir raised and explain about the different aspects like productivity, quality, and the reduction in maintenance. Sir discussed the challenge that facing in machines, focuses on simulation and digital twin, and elaborate why we require digital twin, various softwares for process simulation, machine simulation, and hardware simulation. Sir also focuses on PLK protocol, OPC for controllers, orange box concept to convert brownfield to greenfield. Then sir also covers different aspects like hardware, data, software, connectivity link for different actions, machine learning, long-term storage of data, and so many things. We are very thankful and grateful to you, sir, for accepting our invitation immediately for this 5 days faculty development program, sparing your valuable time, useful experience sharing, and interaction with participants. We assure you that, sir, the learning gained by our participants will be inculcated into budding engineers. Once again, thank you very much, sir. We would like to say special thank to respected Mr. Devraj Patel, sir, Senior PLC Engineer, Bumer Group, UK, Mr. Sunil Jadhav, sir, Control System and Safety Consultant, Immersion Automation Solutions, Dubai, and Mr. Subhash Anokar, sir, Deputy Executive Maharashtra Power Transmission Company Limited, for their presence and grace the session. Thank you all, you sir. We will also like to thank our beloved participants for their presence, interaction, and patient listening. Thank you all.